Hey guys, how's it going? I just wanted to make a quick video today to show you a few samples of what you can do using random chips and selector chips. I was setting up a little game, a little automatic shooting range, and I had a little trouble with these while I was doing it. So I thought it'd be nice to make a little video for anyone else who might be having similar issues that might help you out. So to do this, let's start out by going over how to use the randomizer chip. I'm going to set everything up on this wall over here because I have yet to figure out how to get my chips to spawn in a different direction, and it just makes things a bit easier and neater. So there's our randomizer chip. Now this is going to have three different inputs. Here you've got your generate signal, so anytime that's activated, a random integer is going to be generated and then output from here. Then we've got our minimum value here and our maximum value here. Now, there's a little foible with that I'm going to show you by setting these two values. So let's pull up a basic variable chip here to keep things simple. Of course, you can create a system where those bounds change each time, but for now, let's just use a hardwired variable here. So let's just set that up. I'm just going to connect green to green and blue to blue just to keep everything simple. So let's go to our settings, and let's say for this sample we want to have 4 different possible outputs. We want to do 1 through 4. Now the green signal is going to be your minimum value, so let's set that to 1. Now the blue value is going to be your maximum value. However, this is a little misleading because your minimum value is inclusive and your maximum value is not. And let me hook this up and show you what I mean by that. So let's go to Tools, Connect. So we've got our min value hooked up, our max value hooked up, but that's not going to be 1 through 4, and I'm going to demonstrate that for you. So I've got a button over here so that we can initialize this system. Let's go ahead and connect it up. So every time I hit this button, a random number is going to be generated. And let's get an output chip so we can see what's happening. Now this output chip here, for anyone who's not familiar with it, is just going to show you whatever value is going to the red connector node. So let's get that all hooked up. Now each time I press this button, a value should be generated. Let's bring that closer to us actually. Come on, come on. Okay, so let's put that over there so it's in our field of view. And now every time I push this button over here, it should generate a random value. So we've got a 1, 3, 1, 1, 3, 2. Now I'm going to keep pressing this and you'll notice something, and that's that a 4 never pops up. Because as I said, our maximum value is not inclusive. So you're going to need to go 1 higher than whatever you want that max value to be to get that output. So let's go ahead and set that, and I'll show you that it works. Set that to 5, and now let's try that again. There we go, RNGesus has blessed us. We've got a 4. And, of course, technically I would have to hit this infinite times to prove that is not going to output a 5, but you're just going to have to take my word for it. So let's get this hooked up to us. Oh, one more thing before we move on. There are 2 options that you can use for this randomizer chip. Now you can either set it to be a pulse or continuous. So it's either going to be a continuous output or it will momentarily pulse one of the random numbers. Now, it's useful to have this variation because let's say you're using your randomizer to, say, trigger a gizmo like a rotator or a piston. Having a constant value output is probably a good thing. However, it can cause a glitch, or not a glitch, just if you don't think about this, it's going to have you running into trouble later on if you've got a combinator set up to hold a variable. So let's say you've got an input going into here, but then you also have this set up to backflow to hold the variable. Now let's get ourselves another output. And let's take that with us. So we're going to put that just there and connect it up. There we go. So right now nothing is being output and we have the randomizer set to pulse. So when I press this, it's going to pulse once, but then that variable is going to be held by our combinator there, which is useful for a lot of different applications. However, something you have to watch out for if you have a setup like this is accidentally switching your randomizer to continuous. If you do that when you hit it, it's not just going to pulse that value, it's going to continuously feed that value into your combinator, and you're going to get a runaway number like that. So you don't want it set up that way. Let's go ahead and turn off continuous, put it back on pulse. Oh, and one other thing, it's going to remain in whatever state it's in until it gets another signal. So you can see it's still outputting the continuous 2 until I hit the button again. So from here, let's see how we're going to use this with a selector chip to create a randomized selection gate. And that's useful for a lot of different applications, whether you're building a small game or mazes. Like I said, I was making an automatic gun range where you had doors go up randomly and targets to shoot. So let's disconnect these two here and get our selector into the mix. And we're not going to need this anymore. I'm just going to put it kind of out of the way over there. Okay. So, got our randomizer hooked up and we've got our output behind us. Let's go ahead and pull up the selector chip. Now, the selector chip looks a little intimidating when you first pull it up, but it's pretty simple. So let's pull up our connector tool. So you've got two inputs here, and one of them is going to be the input that goes through the logic gate of the selector and decides which output is going to be activated. This right here, the signal variable, is going to be what is output from those gates. So say if you have a 4 come in here and that triggers the second gate, it's not going to output a 4, it's going to output whatever you put into there. So to keep things simple, let's just set that as a 1. And we're going to use our existing variable just to keep ourselves low on the overall number of chips. So let's connect that up. So now, whatever the logic gate outputs, it's going to output a 1 from the corresponding node. So let's also hook up our randomizer to this. So we're going to have a number between 1 and 4 coming into this randomizer. Let's take a look at its settings real quick. So you can see how this sort of corresponds to the chip. I'm just going to hold them up next to each other, where you've got your output here coming in, or your input here coming in, and then you've got a very simple equation, either equals, less than, greater than, not equal to, and you can have 7 different very simple equations run out of any given chip. So we're only going to need 4 for this one, and we're trying to see what the number is between 1 and 4 and have something different happen in each state. So luckily that's pretty simple to do. So there we go. Sorry about the sway. It's daylight right now, and my motion controllers are a little glitchy. So let's get this hooked up, and we're going to need 3 more of these output chips so we can monitor what's going on. There we go. Sort of set those up in a little array there. And let's hook them all up. Okie dokie, so that's 3 and 4. And let's go back and make sure I have this set to, I want this on continuous in this case so that we can easily monitor what's going on. Okay, let's put a value through. So we've got a 3, and lo and behold, the corresponding logic gate activates. A 3 is input, which, let's grab the settings for that, is going to go through the third logic gate equal to 3. That's activated, and it outputs a 1, which is the value we have going to the green node here. Now, let's see what happens if we have two cases that are both true in the same group of equations. They are not all processed at exactly the same time. This system is going to prioritize whichever one comes first in this listing. And let me show you what I mean by that. Let's set a few different things to equal to 3. So when we have this set to first, every time a 3 pops up, the only one that's going to get triggered is the first one. Now, if we switch it to all, every gate that's true for will output the value from your green node. Now, what happens if, say, you have two that are true and you have first activated? Well, it's just going to go with the first one, and that's regardless of the type of equation. Whether it's less than or equal to, it's not going to prioritize that way. It's going to prioritize based on which one is activated first in the physical list. So keep that in mind when you're using these. So that's pretty much all you need to know about randomized and selector chips for setting up basic games and things like that. I hope the video was helpful to people who are having trouble with that, and leave any comments on how I might improve my videos in the future. Thanks. Have a good day.